Hi! Today we'll discuss about linear ordinary differential equations. Before we proceed with the solution of linear ordinary differential equation, define muna natin ano ba yung n-order na differential equation. A linear differential equation of order n in the dependent variable y and independent variable x can be written in this form, where a sub o is not identically 0. Bakit siya hindi pwedeng 0? Kasi kapag 0 yung first term natin, meaning hindi na siya nth order, magiging n-1 order na siya. Observe natin ano bang meron sa form na ito. Number 1, yung dependent variable y and its derivative occurs to first degree only. Pansinin ninyo, lahat ng derivative natin is first degree lang. And meron tayong y dito, first degree lang din siya. Second, no products of y and any of its derivative are present. Meron tayong product dito pero function siya ng x and derivative ng y. Same thing dito, and hanggang sa dulo. So function ng x then y. Walang product ni y and its derivative. Number 3, no transcendental functions of y and any of its derivative occur. Pag sinabi nating transcendental functions, these are not algebraic functions. Ang example nito is logarithmic, trigonometric, exponential, or inverse trigonometric function. Kapag nakakita tayo ng function ng y na transcendental, automatically that differential equation is nonlinear. Let us consider an example of a linear differential equation. Example number 1, this is a second order na linear differential equation dahil yung highest derivative natin is 2 and linear because lahat ng derivative natin is of first degree, walang product ng y and its derivative, and finally, walang transcendental function of the dependent variable na y. Kaya this is linear. Second example, this is a linear na fourth order differential equation. Highest derivative is 4. Walang product ni y and its derivative. May product dito pero function ni x and derivative ni y. Meron man tayo ditong transcendental function na e pero siya naman ay function ng x kaya ito ay linear pa din. Let's consider these examples and identify natin kung siya ay linear or non-linear. Number 1, y double prime plus 5y prime plus y equals cosine x. This is a second order na differential equation and siya ba ay linear or non-linear? Check natin. This is of first degree, so okay lang. Ito, first degree lang din siya, kaya lang merong product ni y and ng derivative niya. So this is automatically non-linear. Meron man tayo rito ang transcendental function pero function naman ng independent variable. Second, y prime squared plus y squared plus k equals 0. This is a first order na differential equation kaya lang second degree siya. Tapos meron tayong y dito second degree din kaya naman itong differential equation na to is also non-linear. Considering the third example, x squared dx plus sin x dy equals 0, pwede natin itong isulat in two form. Una, kapag dinivide natin by dx, yung buong equation, we'll get x squared plus sin of x, derivative of y with respect to x, equals 0. This is a first order na differential equation and i-check natin kung siya ba ay linear or non-linear. This is of first degree, walang product ni y and its derivative, and lastly, walang transcendental function of the dependent variable na y, kaya naman this is linear. Next, kapag dinivide naman natin yung buong equation by dy, we'll get x squared, derivative of x with respect to y, plus sin of x equals 0. This is a first order differential equation in the dependent variable na x. First degree siya, pero si x natin dito ay second degree. Tapos may product ng x and its derivative. And finally, meron din tayo ritong transcendental function ni dependent variable na x. Kaya naman, this is nonlinear in the dependent variable x. Now, let us try to determine the method of solution ng first order linear differential equation. Linear first order differential equations, independent variable na y and independent variable na x can be written in the form na derivative of y with respect to x plus p is a function of x times y equals q as a function of x. Notice na lahat ng derivative of y is of first degree and y is also of first degree. Walang product ni y and ang derivative niya, and walang transcendental function of y. So this is a linear first order differential equation. An example is x derivative of y with respect to x plus x plus 1y equals x cubed. Divide natin yung buong equation by x. Then we can rewrite this as derivative of y with respect to x plus quantity x plus 1 divided by x times y equals x squared. We have written this in the form na derivative of y with respect to x plus p as a function of x times y equals x squared, which is q as a function of x. Let us try to rewrite this equation in the form na m dx plus n dy equals 0. Multiply natin yung whole equation by dx. We'll have derivative of y plus p as a function of x times y, derivative of x, equals q as a function of x dx. Yung pagsama-samahin natin sa left side, lahat ng may dx and lahat ng may dy. So, i-combine na natin tong dalawang to. Then, factoring out dx, we'll have p as a function of x times y minus q as a function of x dx plus dy equals 0. Continuing from our previous equation, we have written this in the form na m dx plus n dy equals 0. Check natin kung yung equation ba na to ay exact. Taking the partial derivative of m with respect to y, p as a function of x is taken as constant, then derivative of y is 1, minus q of x is taken as a constant, kaya ang derivative niya with respect kay y ay 0. Simplifying this, we'll get p as a function of x. Then taking the partial derivative of n with respect to x, n is equal to 1. Derivative with respect to x, that is 0. As we can see, partial of m with respect to y, p of x, is not equal to partial of n with respect to x, which is 0. This can only be equal if p as a function of x is equal to 0. But in that case, yung equation na isa-solve natin is hindi na linear. It can be solved by variable separable. Since partial of m with respect to y is not equal with partial of n with respect to x, then this differential equation is not exact. Notice that if we divide the difference of these two by n, from our previous topic, kapag ang pinang-divide natin is n, ang ina-expect nating function ay function ng x. And yung ina-expect din natin integrating factor is also a function of x. Tingnan natin ano bang makukuha natin kapag pinreform natin to. 1 over n, that is 1 over 1, multiplied by p of x minus 0. We can see na ang makukuha natin dito is p as a function of x, which is consistent with this. Therefore, the integrating factor for this linear first-order differential equation is equal to e raised to the integral of this term, which is just equal to p as a function of x. Dahil meron tayong integrating factor, we can now multiply this with our differential equation, and this will now be exact. Multiplying this with this, e raised to the integral of p function of x dx multiplied by p as a function of x y minus q as a function of x dx plus e raised to the integral of p as a function of x dx dy equals 0. Distributing this, then distribute ko na rin sa dx. Dahil na-multiply na natin yung ating differential equation by the integrating factor, we know that this equation is now exact. By method of grouping terms, isolve natin yung ating differential equation. Ang una kong pipiliin is yung kasama ni dy. So, integrate natin siya with respect kay y. Dahil with respect kay y, yung integration, ito ay taken as constant. And ang integral ng dy is y. To get the partner of this term, dun kay dx, i-differentiate natin yung result. This is equal to, ang differentiation ay with respect kay x, this is taken as constant, times ang derivative ng e raised to integral of p of x dx. Kunin natin yung derivative ng exponent ni e. So, ang derivative ng integral is just the term inside, that is p, as a function of x multiplied by e raised to the integral of p of x dx. Notice that this is also equal to the first term. And ito yung term na kasama doon sa general solution. Notice na natitirang term na lang is yung second term, which is a pure function of x. Kaya ang maging partner niya kay y is 0. Therefore, the general solution of any linear first-order differential equation is equal to this term minus the integral of e raised to p as a function of x dx. Q of x with respect to x equal a constant. Pwede natin gamitin ito sa mga problem natin, or we can also apply the method of solution for exact equation after we found the integrating factor. Solve tayo ng sample problems to see how this works. Sample problem number 1. Derivative of y with respect to x plus 2x plus 1 over x times y equals e raised to negative 2x. Notice that this is a linear first-order ordinary differential equation kasi this is just a function of x multiplied by y equals q as a function of x. To solve this, let us identify the integrating factor. Then later, follow na lang natin yung general solution for a linear first-order differential equation. The integrating factor mu is equal to e raised to the integral of p of x dx. And this is equal to e raised to the integral of quantity 2x plus 1 over x dx. Simplify natin to by dividing the whole equation by x. 2 plus 1 over x dx. Then taking the integral of this, copyin lang natin si e. The integral of 2 dx is 2x plus the integral of 1 over x dx is ln of x. Pwede natin itong isulat as a product of e with exponent na 2x and e with exponent na ln of x. Simplifying this, that is just equal to x, then multiplied by e raised to 2x. The general solution is written as the integrating factor multiplied by y minus the integral of the integrating factor multiplied by qx dx equals c. Yung integrating factor natin is this term times y minus the integrating factor multiplied by q as a function of x equals c. Ito muna isulat natin. Simplify natin to. E raised to 2x times e raised to negative 2x is just 1. So, matitira is the integral of x dx. And integrating this, that will result to minus x squared over 2 equals c. Simplify lang natin yung whole equation by multiplying the whole equation by this is now 2x e raised to 2x times y minus x squared equals 2 times a constant is still a constant. Kaya pwede pa rin natin itong isulat as c. Mapapansin niyo, very simple lang siya basta alam nyo kung paano yung form ng general solution. Take note, kapag na-solve nyo na yung integrating factor, you can multiply this by the original differential equation and then solve by exact equations. Problem number 2, y prime equals cosecant of x plus y cotangent of x. Sulat natin si y prime as derivative of y with respect to x, then lipat na natin to sa left-hand side. This is now of the form na derivative of y with respect to x plus p as a function of x equals q as a function of x. Identifying p as a function of x, that is negative cotangent of x, and q as a function of x is cosecant of x. The integrating factor, mu, as a function of x is equal to e raised to the integral of p of x dx. This is equal now to e raised to the integral of negative cotangent of x dx. We can also write cotangent of x as, labas ko lang si negative, the ratio between cosine of x over sine of x. Taking the integral of this, if we let sine of x as u, then take its derivative, that is equal to cosine of x dx. Therefore, the integral of negative cotangent of x is negative ln of sine of x. Then by logarithm rule, pwede natin gawing exponent si negative 1. And this is also equal to e ln of 1 over sine of x. Or this is just equal to 1 over sine of x is also equal to cosecant of x. So this is now our integrating factor. Following the form of the general solution of linear differential equation, we have the integrating factor multiplied by the dependent variable y minus the integral of the integrating factor multiplied by q of x dx, that is equal to a constant. Ito na lang yung kailangan natin i-integrate. Simplify lang natin to. Rewriting y cosecant of x minus, simplifying this, cosecant squared of x dx equals c. This is equal to negative cotangent of x. Simplifying, y cosecant of x plus cotangent of x equals c. Express natin to as ratio. This is 1 over sine of x plus cosine of x over sine of x equals c. Remove natin yung denominator by multiplying the whole equation by sine of x, and we'll get y plus cosine of x equals c sine of x. Expressing this explicitly, c sine of x minus cosine of x. And this is now the general solution of this differential equation. Problem number 3, y squared dx plus quantity 3xy minus 1 dy equals 0. I-write natin siya na nasa form ng dy over dx plus p of x times y equals q of x. We can do that by dividing the whole equation by dx and 3xy minus 1. Y squared all over 3xy minus 1 plus derivative of y with respect to x. This is equal to 0. Ang gusto natin, mapalabas na siya ay linear equation in the dependent variable y. Notice dito na second degree si y. Therefore, hindi siya linear. Hindi rin naman siya homogeneous kasi ito ay hindi second degree. Hindi rin siya variable, separable. Dun sa ating kaninang example, nakita natin na pwede natin ipag-interchange si x or y as the dependent variable. So, isulat natin to na ang gawin naman natin, ang dependent variable is x. We can do that if we divided the whole equation instead by dy and y squared. Divide natin siya by dy and y squared. We'll have derivative of x with respect to y plus 3xy minus 1 divided by y squared equals 0. Simplify natin to. 3xy over y squared, we can cancel y, divided by y minus 1 over y squared equals 0. Lipat natin to sa kabila. Derivative of x with respect to y plus 3 over y times x equals 1 over y squared. We can notice here na siya ay linear in the dependent variable x, and ang form niya is derivative of x with respect to y plus p as a function of y multiplied by the dependent variable x equals q as a function of y. Linear pa rin siya pero in x na. Nag-interchange lang yung dependent variable and independent variable, kaya yung ating integrating factor mag-interchange din. Function na siya ng y, and that is equal to e raised to the integral of p function of y dy. Solve natin to. Palit lang natin si p sa function of y. 3 over y dy. This is equal to 3 ln of y. Gawin natin tong exponent ni y. And simplifying this, ang matitira na lang is the term inside ln. Dahil x na yung ating dependent variable, yung general solution natin, magkakaroon din ng slight modification. That is now equal to the integrating factor multiplied by the dependent variable minus the integrating factor times q of y dy equals constant. Palit lang natin yung nakuha natin na value dito, which is y cubed multiplied by x minus, this is again y cubed, times q of y is 1 over y squared dy equals c. Simplifying this, and sulat ko muna pala to, minus, simplifying this, we have y dy equals c. Taking the integral of y dy, that is y squared over 2 equals c. Tanggalin natin tong denominator na 2 by multiplying the whole equation by 2, and we'll get 2x y cubed minus y squared equals 2 times a constant, still a constant, that is equal to c. And this is now the general solution of our differential equation. In summary, to solve linear first-order differential equation, we first write it in its standard form. Next, we identify or determine the integrating factor. Third, if you know the general solution of a linear differential equation, you can just plug in the integrating factor and solve for the integral of the remaining term. Or, we multiply it to the whole equation and solve it through exact equation. Yun lang. Galingan niyo palagi and huwag kakalimutang maging mabuti. Bye!